All right, and 54 I think is not even as bad as the other one. But I want to find all the real zeros, so if I want to find all of them, and I want to use the rational zeros theorem to figure out possibilities first, and then do factoring or the quadratic formula. So let me see, the possibilities, or what's the other word we use for possibilities? The potential, I don't know, potential rational zeros would be factors of 10 plus or minus divided by factors of 1. So that's not too bad. That's plus or minus 1, 2, 2 times 5, and 1 times 10. So that's 2, 4, 6, 8 possibilities there. And yeah, I guess I will give you guys a hint for this one too, because I think the idea is we really don't want to have to go through and check every single one of those. 2 of them work and the other 6 don't. So I'm going to go ahead and give a hint of -1. So here's my hint. -1 is a 0. So that means I should be able to put in -1. This is no gaps, so I'm going to have a 1, a -1, a -7, a 5, and a 10. Bring down the 1 and do my synthetic division. I'm going to multiply and add, multiply and add, multiply and add, multiply and add. Yay! That remainder is 0, so that means -1 really was a 0. Yay! So I'm going to go down here and write my real zeros. We're going to include -1. Let's see what else. All right, now I got some options. This is a cubic, so I could go ahead and let's see if I could. Yeah, you know what I'm gonna do? Well, I don't want to confuse you. We could definitely do factor by grouping at this point. So I'm going to rewrite this as 1x cubed minus 2x squared minus 5x plus 10. And I'm going to do factor by grouping. That is good because I don't know what the other zeros are. So I could try doing the synthetic division again, but I don't really know what to put here. -1 worked. I could try +1 or -2 or +2, but a lot of those might not work and have a remainder of 0. So I kind of would like to avoid guessing and checking. So I'm going to factor by grouping. I'm going to look at these first 2, group them together, and then I'll turn this into, I'll move the negative over there, I'll group those guys together. So the GCF of these 2 is x squared, and I'm left with x minus 2. And then if I look at these guys, these also have a GCF of, let's say, I'm gonna say -5. And then I'm left with x, -5 times x is that, and -5 times -2 is 10. So it's actually worked really well. I could do factor by grouping for this one. You can't for all of them, but yay. So now I have x of these guys and -5 of these guys as well, x squared, sorry. So I have x squared minus 5 of these guys all together. Because these do match, we'll put them together here. That's how factor by grouping works. If I FOIL this, I will end up with what I started with, so that's great. Ooh, and I have this -1 here, which means that I guess x plus 1 was another factor. So really all it's telling me to do is find the real zeros, but I want to go ahead and kind of factor as I'm going as well. So x plus 1 is a factor. X minus 2 is a factor. There's a couple ways we can think about this one. We could think of this as a difference of 2 squares. X and x, and then 5 is √5 times √5, right? And it's a difference, so one is positive and one is negative. That is the fastest way to do that. Otherwise, you could also just go ahead on the side maybe and set, I'm gonna write or, you could do x squared minus 5 and set it equal to 0. Then when you add 5 to both sides, you get x squared is 5. And then when you square root both sides, you get x equals plus or minus the square root of 5. Maybe I'll put the square root in a different color here. Put the plus or the minus. It's getting tiny, sorry. So there's the plus or minus root 5 is there as well. So yay. So now this is fully factored. Again, the directions didn't say you had to, but I'm doing it. And now my zeros are -1. Over here we could see that +2 is also a 0. And then from this we can see that negative root 5 is a 0. And from this we can see that positive root 5 is a 0. So I've got 4 zeros, which makes sense because the degree was 4. These are all real, but as a side note, only these first two were rational and on our list of possible rational answers. And these two were irrational because any square root of a not perfect square is irrational. And they're all real. None are imaginary. That's for next class.